ಚಲೋ ಅಲ್ಲ ಅಂತ. ಬಟ್ ಒಂದು ಹೋಮೋ ಆಗಲ್ಲ, ಯಾಕಂದ್ರೆ 2 ಅಟೆಂಪ್ಟ್ ಕೊಟ್ಟಿರ್ತಾರೆ. JE also has its own problems, but nobody talks about that. Because engineers life ಅದು ಏನು ಪ್ರಾಬ್ಲಮ್ ಆದರೂ ಹೌದಾ ಹಂಗ ನಡಿ ಆಯ್ತಷ್ಟೇ, ಮಾಡವ ಏನಾರ ಮಾಡವ ಅನ್ಕೊಂತ. ಎಸ್ okay, so in the previous class we were talking about this. One of the properties of charges is charges are additive in nature. Okay, so yeah, total charge find ಮಾಡಿದ್ರೆ you simply add all the charges along with their signs. ಯಾವ ತರ ಆಡ್ ಮಾಡ್ತೀರಿ? algebraically. ಯಾವ ತರ ಆಡ್ ಮಾಡ್ತೀರಿ? algebraically. Adding vectorially is different from adding algebraically. Algebraically add ಮಾಡೋದ್ರೆ simply +1 -2 will give us -1. Vectorially +1 -2 add ಮಾಡಿದ್ರೆ -1 ಬರಬಹುದು, ಬರದೆ ಇರಬಹುದು, right? Because in vectors you also need directions as well. Okay, now the next property is charge is conserved. Okay, charge is conserved. ಯಾವ ತರ? Yes, for an isolated system, total charge of the system is conserved. Okay, here this is important. Isolated system ಇರಬೇಕು. Isolated system ಇದ್ರೆ the total charge of the system is conserved. Let's say this room is completely isolated from the rest of the world, then the total charge in this, or the total charge in this room, let's say it is 6 coulomb. The total charge in this room, let's say it is 6 coulomb, of which let's say 2 coulomb is with the boys and remaining 4 coulomb is with girls. Now within this system what happens is exchange happens. Is that boys some of their charge they give it to the girls, girls some of their charge give it to the boys, something like that happens. So let's say after that exchange your hatra 1 coulomb udidre, right? With the boys if there is only 1 coulomb, what will be the charge with the girls? 5. Why is it 5? Because we are saying that this classroom is an isolated system. So within this isolated system, some of you have 2 coulomb, some of you have 4 coulomb. Now something happened, some exchange happened. ಅವಾಗ ಮಾಡ್ತಿರಲಿಲ್ಲ, ಎಕ್ಸ್ಚೇಂಜ್ ಮಾಡ್ತಿರಲಿಲ್ಲ. ಅದರ ಎಕ್ಸ್ಚೇಂಜ್ ಆದಾಗ ಏನಾಗಿದೆ? Boys have 1 coulomb, then how many will girls have? 5 coulomb. Why will they have 5 coulomb? Is because the total charge of the system should come out to be, because it is an isolated system, the total charge will remain same. But that does not mean that individually charges change agbardu antala. Individually charges can change. Okay, but what happens is the total charge should remain same. Okay, this is another. Let's say now there is another exchange. Here we have how much charge the girls will have? 0. Why? Because the total should come out to be 6. Okay. Now, of many conservation principles, conservation of charge is also very important. Okay, conservation principles have conservation of momentum, conservation of energy, and conservation of charge. Okay, these three conservation principles are extremely important because using these three fundamental conservation charges, ನಮ್ಮ ಮ್ಯಾಟರ್ ಅಲ್ಲಿ ಏನೇನಿದೆ ಅದರಲ್ಲಿ ಮತ್ತೆ ಏನೇನಿದೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಡಿಸ್ಕವರ್ ಮಾಡಿದ್ರೆ ಮ್ಯಾಟರ್ ಕನ್ಸಿಸ್ಟ್ ಆಫ್ ಪ್ರೋಟಾನ್ಸ್ ಆ್ಯಂಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂತ ಡಿಸ್ಕವರ್ ಮಾಡಿದ್ದು ಬಿಕಾಸ್ ಆಫ್ conservation principles. And within this nucleus, within this proton also there is something else called as quarks, gluons and all those things, right? So those particles were also discovered because of these conservation principles. So as principle goes, conservation of charge is extremely important. Okay, ಎಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ ಅಷ್ಟೇ ಸಿಂಪಲ್ ಆಗಿನೂ ಇದೆ. ಎಸ್, ಓಕೆ. Now, from the perspective of calculations, okay, or numerical questions, this property is very important. As charge is quantized. Okay, quantized andre ಏನು? Quantized or discrete. You have learnt about this in structure of atom as well in chemistry. First. Now, let's say you have an object here. This is a neutral object. So if it is a neutral object, if you want to charge it, what you will do? If you want to make it positively charged, what will you do? Remove an electron. Yes. If you want to make it more positively charged, what you will do? You will remove another electron. Yes. So when you are removing electrons and charging this object, you can only either remove one electron, or you can remove two electrons, or you can remove three electrons, or you can remove four electrons. Can you remove 1.5 electrons? Can you remove 2.5 electrons or 3.5 electrons? Okay. So one electron ತೆಗೆದ್ರೆ ಎಷ್ಟು ಚಾರ್ಜ್ ಬರುತ್ತೆ ಅಂದ್ರೆ 1.6 into 10 power minus 19. ಅದೇ ಎರಡು ಎಲೆಕ್ಟ್ರಾನ್ ತೆಗೆದ್ರೆ 2 times 1.6. ಅದೇ 3 ಎಲೆಕ್ಟ್ರಾನ್ ತೆಗೆದ್ರೆ 3 times. Here, if you want to calculate the charge, what you are doing, you are multiplying an integer with what? You are multiplying an integer with 1.6 into 10 power minus 19. Okay. So this is the fundamental magnitude of charge. Okay. And yavade object mele charge idre, that will be an integral multiple of this charge. Okay. So either it will be 1 times that, it will be 2 times that, or 3 times that. If it is positive, it will be plus 1 times, plus 2 times, plus 3 times. If it is a negative charge, it will be minus 1 times, minus 2 times, or minus 3 times, or minus 100 times. Yes, if you remove 100 electrons, it will become minus 100 into. So quantization ಏನಾಗುತ್ತೆ? Quantization here, charge on any object is an integral multiple that is, if you want to write in terms of formula, charge on any body Q will be written as plus or minus n into what is here? What is E here? Fundamental charge, fundamental value of charge. Others to E is 1.6 into 10 power minus 19. Charging methods ಕಲ್ತಿದ್ದೀವಿ. Charging methods ಅಲ್ಲಿ the important thing is how do you charge? Either only by transfer of electrons. Transfer of electrons alli enagutte, either you can transfer 1 or 2 or 3 or hundreds of electrons, only integral values of electrons you can transfer, not half an electron. Okay, although you can divide proton, electron na divide madadಕ್ಕೆ ಬರಂಗಿಲ್ಲ. Okay, electron is one of the most fundamental particles of matter. Okay, take a look at this example. What does it say? Calculate the charge if it has 60,000 electrons. Okay. It has 60,000 electrons only anta varukana. .6 into 10 power minus 15 plus or minus minus. When do we use plus? We use plus when it is a positively charged object. We use minus when it is a negatively charged object. So in this, because it only contains electrons, right? So this is a negatively charged object. So negatively charged object. So charge formula Q will be equal to minus n into E. Okay. What will be the value of n here? The value of n here, it will be 60,000. Okay. So this will be minus 60,000 is 6 into 10 power into 3 multiplied by what is the value of E? The value of E is 1.6 into 10 power minus 19. This comes out to be 16 6 are 96. Yes, minus 9.6 into 10 power minus 15. Simple enough? Yes? Okay. Now, calculate the charge in an object if it has 10 protons and 6 electrons. And you want to calculate the total charge on any object, the formula that you will use is Q is equal to plus or minus n into E. Okay. The only difficulty you will face is n value ಏನು ತಗೋಬೇಕು. First ರಲ್ಲಿ ಬರೇ electrons ಇತ್ತು, n value you can directly take it as 60,000. In the second one, what do you take? You have 10 protons and 6 electrons. Before that, what is the value of n? So if you remember here, n value ಏನು ತಗೋಬೇಕು ಅಂತ ಇಲ್ಲಿ ಹೇಳಿದೆ, right? Let go. Yes. N is equal to difference in number of protons and number of electrons, right? So this is the n that we will use when we are calculating what? When we are calculating charge on this object. Okay. Now here will it be number of protons minus number of electrons? So number of electrons minus number of protons. Number of protons minus L. So n will be equal to 10 minus 6, which is equal to 4. Yes, 10 minus 6, which is equal to 4. And then because protons are more than electrons, this will be a positively charged object. Therefore Q will be equal to plus n into E, which will be equal to plus 4 into 1.6 10 power minus 19. Therefore Q is equal to as per the 6.4 into 10 power minus okay. Here one more question that they will ask here is is a charge of 9 into 10 power minus 19 coulomb possible? Okay. For this also what we will use is we will use this formula only, and then if n comes out to be an integer, we say that yes, it is possible, and if n does not come out to be an integer, we say that it is not possible. Okay. So the charge on the object is how much? 9 into 10 power minus 19. Okay. So what we'll use is we'll use this Q is equal to n into E. Okay. So from here you will get n is equal to Q divided by E. So Q divided by E is how much? This is 9 divided by 1.6. Yes. Is it an integer or is it a fraction? This is not an integer, yes? So there, because this is not an integer, we say that this charge is not possible. Finally you say that because n is ಅರ್ಥ ಆಯ್ತಾ? Yes, ಯಾವ charge possible, ಯಾವ charge possible ಅಲ್ಲ ಅಂತ. That's why we say that charge is quantized, is that is 1.6 in 10 power minus 19 ಅಥವಾ ಅದರ ಡಬಲ್, ಅದರ ಟ್ರಿಬಲ್, ಅದರ 4 times ಅಷ್ಟೇ ಬರುತ್ತೆ. That's why we say that charge is quantized. ಇದರ ಪರ್ಟಿಕ್ಯುಲರ್ ಕ್ವಾಂಟಿಟಿ ಇದೆ, ಆ ಕ್ವಾಂಟಿಟಿ ಇಂಟಿಗ್ರಲ್ ಮಲ್ಟಿಪಲ್ ಇದೆ. Yes. Finish this. Now, even within this also there is an exception. When the charge is very large, let's say you are trying to calculate. Next question. The previous example it was 9 into 10 power minus 19 coulomb. This example is 9 coulomb. Okay. So they ask you if this 9 coulomb is possible, what you will do is you will follow the same rules, and you will say that Q on a body is 9 coulomb, which is equal to n into E. Okay. So from here you will write that n is equal to 9 divided by 1.6 into 10 power minus 19, which is coming out to be 9 into 10 power 19 divided by 1.6. 6. Now, although here n is not coming out to be an integer, but because this is a very large number, we assume that yes, this is possible. Okay. So this is taken as, sorry, and we say that yes, 9 coulomb is what specifically you have to note here is charge ಬಹಳ ದೊಡ್ಡದಿದ್ದಾಗ ಕ್ವಾಂಟೈಸೇಷನ್ ರೂಲ್ ನಾವು ಇಗ್ನೋರ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಎಸ್, ಚಾರ್ಜ್ ಬಹಳ ದೊಡ್ಡದಿದ್ದಾಗ ಕ್ವಾಂಟೈಸೇಷನ್ ರೂಲ್ ಕ್ಯಾನ್ ಬಿ ಇಗ್ನೋರ್. Okay, yes, very specifically sometimes this question has been asked, when can quantization rule be ignored? When the charges are very large, quantization rule can be ignored. Sir, very large ಅಂದ್ರೆ ಹೆಂಗೆ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು? When you get n as 10 power 5, 10 power 6, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಬಂದಾಗ you can ignore quantization. When the charge is like microcoulomb, okay, or millicoulombs or coulombs, directly coulombs. Microcoulomb ಕಿಂತ ಜಾಸ್ತಿ ಏನಾದರೂ ಇದ್ರೆ there everywhere what we do is we ignore quantization rule. Okay, ನ್ಯಾನೋ ಕೂಲಂಬ್ ಇತ್ತು ಅಥವಾ ಬಹಳ ಕಡಿಮೆ ಚಾರ್ಜ್ ಇತ್ತು ಅವಾಗ ಕ್ವಾಂಟೈಸೇಷನ್ ರೂಲ್ ಇಗ್ನೋರ್ ಮಾಡಕ್ ಬರಂಗಿಲ್ಲ. Calculate the amount of positive charge in 0.5 moles of water. I am not saying that it is positively charged, I am saying that within that water molecule calculate the amount of positive charge present. Okay. Positive charge ಯಾಕೆ ಇರುತ್ತೆ? Because of protons. Yes. So basically if you calculate what is the number of protons, you are calculating how much will be the charge. Yes sir. 1 proton idre charge ಎಷ್ಟಾಗುತ್ತೆ? 1.6 into 10 power minus 19. 2 proton idre charge ಎಷ್ಟಾಗುತ್ತೆ? 3.2, 2 times E. Right? If it is 100 protons, it will be 100 E. So basically here you have to calculate what is the number of protons. And if you calculate the number of protons, to that you have to simply multiply E. You have to simply multiply E. ಅರ್ಥ ಆಯ್ತಾ? ಎಸ್, ಓಕೆ. You can tell me in terms of E. In terms of E. E into 10 power 23. Mm, 6 to 10 power 10 23. Okay. Sorry, 5 into 23. Okay. Okay. Let me ask you a few questions so that you will be able to calculate it correct. Water molecular formula H2O. Okay. Hydrogen has 2 protons. Each hydrogen has 1 proton. So how many hydrogens here? 2 hydrogens. So therefore total number of protons because of hydrogen is 2. Plus oxygen. How do you calculate total number of protons? Atomic number. Oxygen has the total number of protons will be 10. What is this 10? 10 it is 10 per molecule. Yes, it is 10 per molecule. Okay, one molecule of H2O ತಗೊಂಡ್ರೆ ಅದರಲ್ಲಿ 2 proton ಇರುತ್ತೆ because of hydrogen and 8 protons because of oxygen. The total number of protons is 10 per molecule. Now how many molecules are there? 0.5 into Avogadro number. Yes, number of molecules 0.5 into Na, let's take it 6 into 10 power 20. So this is coming out to be 3 into 10 power 23. So therefore total number of protons ಎಷ್ಟಾಗುತ್ತೆ? Total number of protons 3 into 10 power 23 multiplied by 10. Yes or no? This is coming out to be 3 into 10 power 3 into 10 power 24. So this is the number of protons. Yes. Now total positive charge will be equal to how much? 3 into 10 power 24 multiplied by E. 3 into 10 power 24 multiplied by E. 4.8. How much is that? 4.8 in 10 raised to 4.8 10 raised to 5 coulombs. Yes. Now this water molecule is neutral. Yes. So amount of negative charge ಎಷ್ಟಾಗುತ್ತೆ? Same. Yes. Only then it will be neutral. This is the total amount of positive charge. If this is equal to the total number of negative charge, only then that will be neutral. Okay. So here you can simply note down because H2O is neutral. Therefore, amount of negative charge will be how much? Minus 4.8 into 10 power 5. Difficult ಆಗ್ತಾ ಇದೆ ಇದು. Okay. We can make it even interesting. There are a few questions at the end to make this even more tricky. But for now, is this fine? Yes. Okay. So we'll move on to the next one. Yes. ಇಲ್ಲಿ ತನಕ ಇನ್ನೊಂದು ಕಲ್ತಿದ್ವಿ charges additive in nature, charges quantized. ಮತ್ತೆ charges invariant. Actually here this should be relativistically invariant. Okay. Relativistically invariant andre ಏನು? Right, let's say this object, I measure the charge. I'm standing here and I'm measuring the charge and it is coming out to be 2 coulombs. What I do is I take this with me and I start running, okay, at the speed of light, and then I measure what is the charge on this. Even at that time also it comes out to be the same as when I am measuring it at rest. Okay, so that is the meaning of relativistically invariant. Invariant andre change agangilla. So whether you are measuring it while you are at rest or whether you are measuring it while you are in motion, in both the cases the amount of charge will come out to be same. Okay, whereas if you measure mass, okay, let's say the mass of this is 1 gram. If you are at rest and if you measure the mass 1 mandre, when you are traveling at some speed, the mass of this object will actually increase. This is according to Einstein's theory of relativity. What happens is at rest the mass will be different and when you are in motion the mass will be different. So ಅದಕ್ಕೆ ಒಂದು ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ. So this m naught is mass at rest, m is mass when the object is in motion, right? And if it is in motion with the velocity of v, okay, what is this velocity? This velocity is the velocity of the mass with respect to observer, okay. And c is speed of light. Whether you are at rest or whether you are moving at some speed, speed of light is universal constant, is it not? Speed of light is a universal constant. So mass ಈ ತರ ಚೇಂಜ್ ಆದರೆ ಚಾರ್ಜ್ ಏನಾಗುತ್ತೆ? ಚಾರ್ಜ್ ಚೇಂಜ್ ಆಗಂಗಿಲ್ಲ. Okay. Okay, so whether charge is being measured by a stationary observer or whether it is measured by a observer who is in motion, ಎರಡೂ ಕೇಸಲ್ಲಿ ಚಾರ್ಜ್ ಏನು ಬರುತ್ತೆ? ಸೇಮ್ ಬರುತ್ತೆ. Whether you measure the charge here or whether you go to International Space Station and measure, okay. We go to the next one. Okay, you separate again ಬರ್ದಿದ್ದೀವಲ್ಲ. So in your board exam when they ask properties of charges, you have to write these 4 properties of charges. Okay, other than this, few other properties also you can write, but these 4 properties are very very important. What are the other properties of charges? These are common. Like charges attract each other, unlike charges yes, like charges repel each other, unlike charges attract each other. So positive and positive will repel each other, negative and negative will repel each other, whereas positive and negative will attract each other. Okay. But mass alli enagutte, because mass is only one type, right? Between two masses there is only always attraction. Okay, there is only always attraction, whereas here it is both attraction as well as repulsion. Then charge at rest produces electrostatic field. We will try and understand what is electrostatic field, what is magnetic field, what is electromagnetic. Okay, please write.